Factoring. You should be familiar with the distributive law and with the FOIL method. In this lesson, we will factor expressions into binomials. Let's review the multiplication process. First, the distributive law. We have a single term, 3x, which is multiplied by a binomial, x plus 4. The distributive law says we should first multiply the 3x by x to get 3x squared, and then multiply the 3x by 4 to get 12x. In this lesson, we will work on the inverse process, how we can start with the answer, the expanded form, and work back to the factored expression. The FOIL method is similar. We first multiply the first terms in each binomial, then the outside terms, then the inside terms, then the last terms. To get the expanded form, we combine like terms. Once again in this lesson, we will learn how to take the expanded form and work backward to find the factors. There is a special case of the FOIL method called the difference of squares. It occurs when you have two binomials that are identical, except one the two terms are added, and in the other the two terms are subtracted. When we multiply the firsts, we are multiplying 2x by itself to get a perfect square. The outside terms and the inside terms are identical, except one is positive and one is negative, so they will cancel out. When you multiply the lasts, again we're multiplying 3 by itself to get the perfect square 9. This time, when we combine the like terms, the negative 6x and the positive 6x cancel, leaving us with just two terms, both of which are perfect squares. Once again, we will learn the process to take the answer and work backward to find the factors. We will now begin to undo the multiplication performed by the distributive law and the FOIL method. Since we are undoing multiplication, the factoring process is a type of division. We are dividing an expanded polynomial into smaller factors. The first technique is to factor out a greatest common factor. The distributive law multiplied a single term to a polynomial. We now wish to figure out what that single term was. We look for pieces that are common to both terms. We might have a factor of 2 in both terms. 12 is an even number, so 12x has a factor of 2, but 3x squared does not. You may have noticed that both terms have a factor of 3, since 12 is 3 times 4. Is there anything else? Yes, both terms have the variable x. The 3x squared term has two factors of x. Recall that x squared is x times x. The 12x term has one factor of x. Formally, we can break down each term into its smallest possible factors, its prime factors. The coefficient can be factored into prime factors. The variable can't be factored, other than to interpret the exponent as repeated multiplication. We now look for the common factors. We see that each term has a factor of 3 and a factor of x, so the common factor is 3x. We then wish to find the other factor. Here's where the process uses division. The first term is 3x squared. We factored out a 3x. What remains after the factoring? That is, what can we multiply 3x by to get 3x squared? The factor that is left over is x. When we factor 3x out of 12x, we are left with the two factors of 2, which is 4. Here's an example for you to try. You may wish to pause the video and work out the answer. The common factor is 2x squared. We will now start to undo the multiplication performed by the FOIL method. The first technique is the difference of squares. Typically, the FOIL method will produce 4 terms. The difference of squares has just 2 terms. The reason is that the 2 middle terms canceled. This happens when the 2 factors are identical except for the plus or minus sign. All we need to do is recognize which term gets multiplied by itself to produce the factors. To get 4x squared, we multiply 2x by itself. To get 9, we multiply 3 by itself. If we FOILed the factored expression, the middle terms would cancel. Here's an example for you to try. You may wish to pause the video and work out the answer. (16x to the 4th) is 4x squared times itself. Here's another example. What can we multiply by itself to get x cubed? In this case, since the exponent is odd, we can't split x cubed evenly, so this expression cannot be factored. In most cases, when we use the FOIL method, the middle terms combine. We then need to figure out how to split the middle term, in this case, the 11x. Unfortunately, there is no hard and fast rule. The best we can do is make a list of the ways the first term and last term can be factored, and then check if the middle term is correct. In this case, 3 is prime, so 3 can only be factored 3 times 1. It does not matter in which order we write the factors. All we have to do is figure out how to split the 4. We have 2 choices, either 1 times 4 or 2 times 2. But we also have a choice as to which factor the 1 or the 4 pairs with, the 3x or the 1x. Also, the last term was not 4, but instead was negative 4. So one of the 2 constants will be subtracted, but which one? Unfortunately, we need to try each possibility to find the correct one. There are some helpful hints to deal with the signs in the factors. If the constant term has a plus c, then the constant term came from multiplying either 2 positive numbers or 2 negative numbers. If the 2 constants were positive, then the 2 middle terms will both be positive and the bx term will be positive. If the 2 constants were negative, then the 2 middle terms will both be negative and the bx term will be negative. If the constant term in the expanded form is negative c, then there will be one factor with the constant added and the other factor with the constant subtracted. What will the middle term look like? It will depend on whether the outside or inside term is larger. There's one other helpful hint. In this problem, we have a complete list of all the possible ways to factor 12x squared and all the possible ways to factor 28. But how do we mix and match the correct factors? We can eliminate some possibilities. The original expression has no common factors. Therefore, the smaller factors also cannot have common factors. We can't pair up 2 even terms. So 2x could only pair up with 1 and 7, since the other constants are even. The same is true for 4x, 6x, and 12x, since all contain a factor of 2. Instead of 18 possibilities to try, we can eliminate most of them and only try the ones without common factors. The last technique is called grouping. It occurs when the FOIL method produces 4 terms, none of which can be combined. Recall in the FOIL method that the left-hand term in the left-hand factor is part of both the first and the outside, and so is a common factor of the first 2 terms in the FOIL process. We rely on this fact to complete the factoring. We break the problem into 2 halves. First, look for a common factor among the first 2 terms. In this case, both 6x cubed and 15x squared have a factor of 3x squared. We factor the 3x squared out of the first 2 terms. We find that the remaining factor is 2x minus 5. We repeat this process for the second half. 8x and 20 each have a factor of 4. We factor out the 4, and see that the remaining factor is 2x minus 5. We now have a common factor of 2x minus 5, which we factor out. Here is the final factorization. Here is an example for you to try. You may wish to pause the video and work out the answer. The first two terms had a common factor of x squared. The second two terms had a common factor of 9, each leaving a factor of x plus 2. Notice that the first factor is a difference of squares and can be factored further. More than one factoring technique may be present in any given problem. To recap, to begin the factoring process, look for common factors and factor out the greatest common factor. In what remains, if it has two terms, look for the difference of squares pattern. If it has three terms, it likely comes from a standard FOIL process. If it has four terms, try factoring by grouping.